Hey econ students, I want to give you a quick overview of production possibilities models. So one of the things you need to know about macroeconomics is that we're going to deal with a lot of models and graphs and visual representations of economics. Sometimes these graphs are going to be things that are straightforward. Sometimes these graphs are going to use stats and data to try to explain what's going on in the world. Sometimes we're simply going to look at distribution of things as they go along, and sometimes we will try to explain relationships between what's going on. Sometimes we will even look at, are we doing the right thing in the right order, and are we putting things together in a way that makes sense? So as we refer to models in economics, what we're basically saying is that we're looking at graphs. There's some sort of representation of what's happening, and properly labeled, these can take the place of a lot of what's happening. Instead of writing an essay, I can show you the change in a graph. Now, we make some assumptions, the first one being that all other things are equal. When I show you a graph, I am representing the world to you. And so I say that I have what we call a ceteris paribus assumption. Now that's just a fancy Latin word. To give you a good example of what's going on, let's tell you about the ceteris paribus fairy. He is Latin for all other things held constant, and what he's going to do is make sure that your graphs truly represent what you want to show. So, for example, if this is Hootie the dog, Hootie's a good dog. When he goes on walks, he likes to walk with his owner, he likes the sunshine, he likes the grass, he likes the flowers, and he is in a ceteris paribus condition. If the conditions during his walk change, his behavior might change as well. So let's say that a squirrel runs across his path. He is not going to be a good dog. He's going to go run off after it. So, because the ceteris paribus condition changed, his behavior changes. So, if we apply this to economics, the ceteris paribus fairy allows us to make predictions with confidence about his behavior during a walk, as long as something doesn't change that affects his walk conditions. Now, it's like taking a photograph. If I take a photograph of your house right now, or the classroom where you're watching this video, you can count how many people are in the house, how many chairs are in the house, how many boys there are, how many girls are there, how many blue shirts are in the closet. And those photographs, if you will, those graphs that we make, can tell us about what's going on. As we work through macroeconomics, you're going to start to see that sometimes we need a series of photographs, a series of graphical representations to show us what's happening in the world. Your first big model will be called a PPF. Sometimes you'll see this as a PPC, a production possibilities curve. They're just talking about the line. So PPF, PPC are basically interchangeable. But so a PPF is going to show us the possible points of production for an economy with a given set of resources and technology. And the easiest way to kind of remember what this is break down the words. For production, I'm saying what are the inputs that I have and what are the outputs that I can create. For possibilities, given the state of the world, what can I produce? How much labor do I really have? How many working hours can I use to make these inputs become the product that I'm looking to make? And the frontier, that line, that curve, is going to always have a negative slope. It's going to represent opportunity cost, which, if you remember from previous lessons, is what you give up to get what you need. We are going to assume that all of your resources are going to be used efficiently. And remember, ceteris paribus, if the economy's resources or technology change, the PPF will have to change as well. So what does this guy look like? Well, if you look at the graph on the right side of the screen, you're going to have a set of axes and you're going to have a simple curve. What we're going to do is reduce an entire economy to two commodities. In this case, your economy can either make coffee or paper clips. The economy is going to be using the best known technology and utilize the best available resources to produce these goods. The curve itself, the line that you see here as it goes along, that is going to show our maximum possible sustainable output in this economy. And we'll talk a little bit about that later. So as I'm starting to look at one of these graphs, in this one we've got calzones and pizza. I've got a series of points on these lines, and let's kind of break it down a little bit. What you see here is that if I use all of my possible resources and I focus on calzones for the day, I can make 8 calzones. If I use all of my resources possible, I can make 8 pizzas. But there are a series of combinations that fall in the middle. If you look at point A, maybe I want to make a lot of calzones, but also 2 pizzas. If I know I want to make 2 pizzas, I'm going to say, look, I can only make 6 calzones today, because I know that the line, that PPC, is going to show me my maximum possible output. I could say, hey, I want to make half and half. I want to make 4 calzones and 4 pizzas. That would put me at point B if I am being completely efficient and functioning as best I can. Sometimes, however, you are not going to be efficient. Something will interrupt you. Maybe the oven doesn't work. You run out of cheese for your calzone, whatever it's going to be. If you have a problem and you are not 100% efficient, you're going to be inside that PPC line at a point like point C, where you're going to make some calzones and you're going to make some pizza, but because you got distracted and you couldn't do the best possible work, you're not going to have the maximum possible output. If you look out to the side, point D is currently listed as not feasible. Well, that's because I can't make 8 calzones and 8 pizzas with the resources that I currently have. So I have to change what I'm up to. How do I get beyond my current production possibilities frontier? I have to change the ceteris paribus condition. I have to change my world. So there are some ways to get there. To get to point D, you either need more people. If I have more workers, I can make more stuff. I need more technology. Maybe I need another oven for my pizzas. Maybe I need a robot to make my calzones. I need more resources. So maybe I just need more cheese, more flour, more water to make the foods that I am making. I need more capital. So maybe I need more space in my restaurant kitchen. Maybe I need a bigger kitchen. I need more education. Maybe if I teach my chefs to be more efficient or to cook faster, they can be better and create more things for me. The other thing that will get you to point D is trade. What if I make the calzones and the restaurant next door makes pizzas and we swap with each other? We can overall end up with more stuff at the end of the day. So remember, to get to point D is not currently possible at a sustainable level. You could get there, but let's say my maximum output today is 8 calzones. If I also want 8 pizza, I have to work twice as long. Therefore, either I work a double day and I end up so tired at the end of the day that tomorrow I just can't go to work, or I've given up all the resources in my kitchen and I can't make food tomorrow until I go grocery shopping. So that's going to put me inside my curve at somewhere like point C for the following day. If I want to stay at point D and be sustainable, I have to do the more people, more technology, more resources list of things to get me there. So sometimes you're going to see simple numbers. They're going to say, I have represented a PPF with the following numbers. I'm either going to make potatoes or tractors. It's Idaho, let's go with it. So if I put all of my effort into potatoes, I can make 54, we'll say, tons of potatoes. If I put all my effort into tractors, I can make 9 dozen tractors. We'll go with it. And you'll see that the graph that you're looking at is going to show opportunity cost. If I want to go from making 0 to 1 tractors, I have to give up 2 tons of potatoes that I could potentially have been making. So if I put this on a graph, I'm going to have potatoes on one axis, tractors on the other, and I'm going to create a line that shows either I make 9 or 54. Remember, everything underneath the curve in that green triangle is a possible thing. If I'm being less efficient and being off the line, I can be in that green zone. If I am outside my PPF, how do I get there? Maybe I get more acres to grow potatoes on. I hire more labor. I get more raw materials to make tractors. I get a robot to assemble my tractors for me. Remember, if I'm at the yellow star, I'm inside the line. I'm being less efficient and less productive for the day. Now, these graphs that we have been making have a straight line, correct? This implies that opportunity costs is constant and trade-offs are equal. However, in the real world, this isn't true. We call this the law of increasing opportunity costs, because not all goods are equal, unless you go to the dollar store. I mean, everything's a dollar. But in the real world, you have to have trade-offs. I can't just say it's a one-to-one swap for calzone versus pizza, for a paperclip versus a pound of coffee, for a tractor or a ton of potatoes. They're just different animals, and so the trade-offs are going to be unequal. That's going to mean that most of the PPFs that you ever see are going to have curved lines that will show that change in opportunity cost as you move from one product to the next. So the last thing to talk about is that sometimes the world changes and so will your graph. If the ceteris paribus condition changes, there are 6 ways that your PPF can move. I've put all of these up on the screen for you. You can see that the purple line would be your original graph, and the red line will be your change. So let's work through some of these. We're going to pull back your tractors versus potatoes example, and let's work through how these graphs might change. In the upper left-hand corner, what if 5,000 new people move to Idaho? Well, I've got more workers that can do more labor who are going to work on both tractors and potatoes. So overall, I'm going to be able to make more of both. In your bottom left-hand corner, let's say that wildfires sweep through Idaho, taking out factories and farms, and everybody is in devastated situation. Well, then you're going to be able to make less of both. You'll be able to make less tractors and less potatoes. So the entire graph will shrink inward to the red line. Now, you're not necessarily going to have situations that affect both products at the same time. As we work through the next ones, you'll see that. So in the middle of the top, you've got tractors versus potatoes. Let's say we implement robots into the production of tractors. I can make tons more tractors. It doesn't affect my production of potatoes. So as you see, the line is going to stay put where it was on production of potatoes, but you're going to see a shift in the production of tractors. In the same way, let's say there's a disruption in trade that makes it harder to get steel. That's not going to affect your production of potatoes, but it is going to make you less capable of making tractors. And finally, on the right side, as you look at the opposite, let's say that ISU comes up with a new fertilizer that increases per acre production of potatoes. That's not going to affect your tractors. It is going to expand your ability to produce potatoes. And finally, on the bottom right, if you see an outbreak of potato blight that's going to destroy crops, you're going to see a shrinkage in the amount of potatoes that you can create, but it's not going to affect your tractors. So as you go through, please make sure you're looking at, does your graph shift and how it possibly could shift. A last and final note for you as we start to get into economics assignments. As you're answering questions, please look at what the question asks for. How much was left over? What percentage of something or what number of something? Those are different numbers. Make sure you're giving an answer that answers the question. If I ask you what percentage of students watched to the end of this video and you tell me 3, well, are you saying 3 students or 3%? Please be clear. Next, be careful with rounding. Decimals are good. I don't need decimals out to the billionths. But if you want to tell me that the answer is $4.23, please don't round that to $4 because you're losing a good measurement there. Please be sure to give units with your answer if needed. Are you measuring in dollars, yen, rubles, euros, feet, centimeters, tons of potatoes? How are you measuring what's going on? And finally, please give precise answers. He needs to spend less somewhere might be the answer to what's wrong with Joe's budget, but telling me that he needs to adjust $96.26 of spending at a minimum to break even is a much better and more precise answer. Last but not least, please remember that humor is fun, but only accomplished by an excellent answer. There is such a thing as witty and correct. There's also such a thing as witty and wrong. Please make sure that I am laughing while I give you credit, not laughing while I mark it incorrect. Last but not least, I'm going to send you a link to another way to look at PPFs by looking at Monsters, Inc. Take a look at this little video. It may help you with understanding.